Hey guys, in this video I'm going to show another example of finding the gradient of a function, and this one deals with a level curve that is a hyperbola. I've got three other ones that deal with parabolas, circles, and straight lines as the level curves. So this is my friend over here. He's going to assist, and you see he's got a big smile on his face, so try to resist his big grin. Let's see how long it can last. Alright, let's take a look. There you go. Okay. So here's the function. The function looks like this. This is a function f of two variables x and y. So let's write it down. And this one deals with fractions and such. So g of xy, okay, is given by the following. So g is the function, x and y are the variables in the xy coordinate plane, right? These are spatial variables. All right, so let's take a look. And it's given by x squared over 2 minus y squared over 2. And the point where we are going to find the gradient of this function is the point, the root of 2 comma 1. Okay, that's the point where we're going to find the gradient of the function. So, how do we do it? Well, we need the partials and we need the definition of the gradient. So the gradient is defined as a function of x and y. It's got these components, and the components are the partial derivatives. So you can think of the gradient as a kind of total rate of change. It's the rate of change along the x plus the rate of change along the y. So you can definitely think of it as a kind of total rate of change. Well, with this in place, let's actually find the derivatives. Okay? So they look like this. G sub x over here is you use the power rule. The y is constant, so it goes away. It doesn't change with respect to x. In other words, if you fix your x, as you fix y, you vary the x. Okay, so that's what it means. So with respect to x, the y part is constant, so it goes away. It doesn't change. So let's differentiate. So you bring the 2 down. So you have 2x over 2, which is just x. So that's the x component of the gradient. Stick it in. The y component of the gradient is so differentiate. Negative 2y over 2 equals negative y. Negative y. That's the y component of the gradient. Okay, you see it's still smiling, so you've just got to keep smiling no matter what. All right, next. Evaluate the gradient at the point specified. Remember, this is a function of position, which means as you move around the coordinate plane, it changes all the time in direction and magnitude. So the gradient evaluated at the point, the root of 2 comma 1. Okay, so you'll be sure you're seeing this clearly. That means wherever you see x, replace it with the root of 2, and then you write in your I, and then to that you add. Wherever you see y, you replace it with 1, so it turns into negative 1j. Okay? So this is the gradient evaluated at the point, the root of 2 comma 1. With that in place, the next move is this. Let's graph the level curve that corresponds to this point and the function. So the way to do that is to find the value of the function at that point. So now you need g evaluated at the point, the root of 2 comma 1, like this, okay? So we have the root of 2. It's only that portion that is squared. There you go. And then from it, you will subtract. Let me color code this so you see it clearly. 1 squared over 2. So all we are doing is evaluating the function at the point, the root of 2 comma 1. So let's simplify. So the root of 2 squared, of course, is just 2. So you have 2 over 2 minus 1 over 2. So of course this is the same as 1 over 2. So the value of the function at the point, the root of 2 comma 1, yep, that's right, okay. That is equal to a half. So the value of the function at the point, the root of 2 comma 1 is equal to 1/2. That's what we have, okay? That's the level curve. So now we're actually going to sketch the level curve. So the way to do that is construct a coordinate system. Here we are. So once we have our coordinate system, sketch the level curve. So in our case, the level curve is x squared over 2 minus y squared over 2 equals a half. So let's simplify this. This is a hyperbola. And how do we know? Because there's a negative between these terms. We can simplify this by multiplying everything by positive 2. Okay, so this way, the whole equation multiplied by positive 2. So all that remains is x squared minus y squared equals 1. This hyperbola, I'm going to take 2 spaces to be a 1, to the left and to the right. So this is a hyperbola that looks like this. And now the point, the root of 2 comma 1, roughly is about here. And once you've done this, mark the gradient at that point. So it's got an x component of the root of 2. So maybe roughly from there to there, and then 1 down. So that's about that. And then you connect with an arrow. This thick arrow is the gradient at that point, and notice roughly it's perpendicular to the contour curve, the level set. People call these all kinds of names. Okay. So you may want to label this further so it's super clear as the root of 2i minus j, and this is the value of the gradient at the point, the root of 2 slash, comma 1. Okay, so that's the gradient at that point. So to review, you've got to x squared over 2 minus y squared over 2. The root of 2 over 1 is the point. Form the gradient by taking the partials, apply the definition of the gradient, evaluate at the point, as I've done here. To find the level curve corresponding to this point, evaluate the function at that point, and it gives 1/2 in this case. Take the function, set it equal to the 1/2, simplify if possible, represent an xy coordinate plane, mark the x and y components of the gradient, connect with an arrow, and perhaps label the arrow so you know what it actually represents. And remember, this is a kind of total rate of change. It's the change along the x, and then you've got the change along the y. And that is the whole procedure. So thank you for watching, and keep smiling.